Week 2 Cloud Infrastructure Compute Part 2. Autoscaling. For deployments of multiple virtual servers working together in a varying load conditions in the cloud, vendors usually offer some version of autoscaling mechanism. Creation of a server group to which individual virtual servers may be added or removed depending on a set of conditions, like each server virtual CPU load, network bandwidth usage, or time calendar type of conditions. For example, an electronic commerce vendor may want to automatically add virtual servers to their storefront application in the cloud on weekends when more people are likely to shop, and downscale on Monday. Visit this website for more information about autoscaling feature in Amazon Web Services. For such multiple server deployments, cloud vendors also provide a load balancing feature. This is a gateway which can distribute incoming requests among individual servers based on their load or some balancing algorithm. For example, a popular one is round robin, which simply assigns servers in turn. Load balancing can act local, that means confined to a data center, or global, distributing workloads across data centers, even across the globe. Visit this website for information about Microsoft Azure load balancing service. Vendors charge for virtual server in most cases on pay-per-use basis. Remember, this is one of the tenets of cloud computing, hourly or even by minute. When you stop a virtual server, their resources like memory and local storage can be deallocated and server charges stop. However, remote storage and other charges may still be incurred. If your server makes use of such remote disks, they can be retained and the instance can be brought back to life, often on a different physical host, and reattached to those remote disks. Many vendors offer several paying options, like monthly payments if you want to use the servers on continuous basis, or enterprise subscriptions for longer term, like yearly. Amazon even has an option of competing for unused server capacity at a discount. Visit this website for Microsoft Azure pricing information. Because of the ease of virtual server provisioning, the cloud lends itself to horizontal scaling model, in which when need for compute power increases, more servers are added, as in autoscaling. This is the opposite of vertical scaling, where servers running out of capacity are replaced with bigger servers. Horizontal scaling is one of the tenets of cloud computing and applies to other kinds of resources too. Instead of getting bigger, which always has a limitation, you get more, which has less limitations and suits well today's massive applications with strongly variable resource needs. Bare metal servers. Many cloud vendors, although not all of them, offer the capability of renting complete physical servers or bare metal servers without virtualization. You don't have virtual neighbors on such a server, it's all yours. They are more expensive, but they allow clients to have full control over them. Organizations can run specialized applications on such servers or use them for private off-premises cloud, running a dedicated hypervisor and cloud management software on them. Having the whole physical server at your disposal, you may take advantage of various hardware features which are not directly available in virtual servers, like Intel's secure enhancing trusted execution technology. Provisioning bare metal server may take longer than virtual servers, and therefore charges may be more likely monthly. When you stop a bare metal server and don't deallocate it, you keep being charged for it. Let's talk about colocation. Many cloud vendors offer this feature, which allows customers to bring in their own physical servers or other devices and install them in the vendor's data center. This way, customers can take advantage of the provider's power, cooling, physical security, etc., while they own and fully control the hardware. Other devices like network or storage can also be collocated. There is usually a process for the customers to follow to adhere to the provider's security measures. Cloud providers in most cases allow for collocated resources to connect to their cloud offering for them to work together. A typical example is collocating a custom network gateway to provide connectivity between an on- and off-premises hybrid cloud environments. Containers. Recently, another form of cloud computing resource started gaining popularity: containers. So what is a container? While each virtual server carries its own guest operating system, containers run on top of single operating system installed on the host server. Containers are computing units which offer a high level of isolation from each other. Each container is confined to its own namespace. That means it sees only its own file system and memory. Containers are provisioned for containers images which contain libraries and runtimes needed for running a particular application. They don't contain the operating system binaries, so they are smaller. Cloud vendors offer libraries of standard container images as well as support for creation and storage of custom images by the customers. One popular container implementation is Docker, an open source project. This figure illustrates the concept of containers. Virtual machines run on top of the host operating system, are implemented by a hypervisor, and each of them carries its own guest operating system. Whereas containers share the host's operating system, are run by the container engine, which implements the isolation, so the cake has less layers. Creation of a container does not involve installing and booting of the operating system, so they can be brought up and down much faster than virtual servers. Also, container images, because they don't contain the operating system, are smaller and therefore easier to create and use. There is only one operating system involved, the hosts. Since containers are isolated environments, each can have its own set of libraries and runtimes, so applications can run without version conflict even with one shared operating system. The fact that there is one single shared operating system can be also viewed as a disadvantage. You can't run Windows and Linux apps, for example, in containers on a single host. Also, security holes in the shared operating system can influence all containers on a host. Container technology is gaining popularity, and it is being offered by most cloud vendors. It is particularly well suited for deployment of microservices. This is an application architecture, whereas an application is split into independent components, each of them with its own development and deployment cycle. Visit those websites for information about container services available in AWS and Azure. Serverless computing. Last but not least, let's mention the most lightweight compute option, serverless computing. If you just have a piece of software which you want to run in the cloud as a reaction to some kind of an external event, and you don't want to care about provisioning and maintaining infrastructure for it, you may take advantage of serverless computing. It is also called function as a service. You'll have to adhere to a particular way of writing and deploying your code, but the cloud vendor will supply the infrastructure to run it without your intervention every time and release it upon completion. Code to be deployed on a serverless compute has to be stateless, which means that no data can survive across its invocations unless it is persisted externally. Applications best suited for serverless compute are systems handling events coming from a large number of sources which do not require complicated processing, like Internet of Things software. See this website for more information. Most cloud vendors offer serverless computing in some form. Amazon Web Services offering is called AWS Lambda. Here is a website with more information. On the other hand, Azure called it Functions. Visit this website for more information. In summary, this week we learned about compute options for infrastructure as a service in the cloud. We talked about virtual servers, their implementation, provisioning, auto-scaling, load balancing, charging for them, and then generally about scaling in the cloud. Then we talked about bare metal servers and collocation. We also covered containers, talking about their advantages and disadvantages, and serverless computing. Thank you.